This is lesson 4 from the topic of algebra. This exercise of substitution is exercise 2H, which is taken from another textbook. So you will get another set of questions supplied to you by the teacher. You'll use your log sheet to determine which questions you need to do from that handout. So the topic is substitution. To substitute just means to temporarily replace. So when we substitute in algebra, we will be replacing a letter or a variable with a proposed number into either an expression, so something that has an equals, something that doesn't have an equals an expression, or an equation. Generally it's equation or formulas where we would substitute values into. So the first example, I've got the question set up here, but I've got it also on the right hand side to actually get the answer down. We're going to substitute t equals 3 and u equals 4 into the following expressions. So t equals 3 and u equals 4. And all we're simply doing is anywhere you see a t in the expression, you're going to replace it with a 3. In this case, we're not going to actually just put the 3 next to it like a lot of students tend to do. 3t means 3 times t. So in this case, this is equal to 3 times whatever t is, which is 3, plus 4 times whatever u is, in this case, 4. So work out this multiplication first. 3 times 3 is 9. Work out this multiplication second. 4 times 4 is 16. And in this case, 9 plus 16 is 25. Just remember your BIDMAS rules when you carry out this this equation here. You have to do the multiplications first before you do the addition. That's why multiplication comes first, and then addition. The second one is t squared plus 3u. So anywhere we see a t, we're going to replace it with the number 3. So in this case, this is equal to 3 squared plus 3 times u, which is 4. Alright, again, BIDMAS, any brackets, nope, indices or index or anything with a power, we work out first. 3 squared is just 3 times 3, 9. Plus, then we do any divisions, nope. Multiplication, yes. 3 times 4. In this case, it's 12. And go ahead and just add those two up. So 9 plus 12 is equal to 21. So this is the straightforward substitution into an expression. Okay, now this is the next example I've got set up. So substituting numbers into equations works on the same principle. So before we just put it into expressions, this time we'll be putting it into equations. It works on the same principle, but sometimes you will need to use logic to determine how to obtain certain answers. So logic just means to filter through as many possible answers as possible until you get to your desired answer. Okay, so there are different algebraic ways that we can solve, but in this case we're just going to use simple logic because the numbers that we're using is nice and simple. Now on my right here I've got an image of the Casio scientific calculator, and I'll show you which buttons you will need to use, not necessarily for this example here, but for the next one. So what we're going to do is we're going to substitute the given values into the formulas and solve for the unknown. So here we have a formula. M is equal to F divided by or over A, where M is equal to 3 and F is equal to 12. So in this case, any letters that we see within this formula and any numbers that have been given, we're just going to replace them. And whatever's left over, we are going to try to solve for that. So in this case, instead of M, I'm going to write 3. And 3 is equal to, here we have a 12 over, and A, because there's nothing equaling to A here, we're just going to leave it as A. So right now we have this equation that says 3 is equal to 12 divided by some number which we don't know. Now this is where that that little sentence that says logic needs to be used to determine a certain answer. What this means is we know that some number divided by 12 divided by some number rather is going to give us the answer 3. And there's only one possible answer for this to work. In this case, A has to equal 4, because 12 divided by 4 is equal to 3. There's no other number where this can work. So here is our final solution. Now remember how in trigonometry where you had an unknown on the bottom and all we did was swap them around? This actually works in this case as well. If I swapped A around with a 3, what will we end up getting? And I'll write this in a different color. Is A is equal to 12 over 3. We just did a simple swap from here to here. And 12 over 3, or 12 divided by 3 is 4, which is the same answer. Okay. So if you ever get a situation where there's a number on the bottom that you're trying to solve, and you have these two numbers filled in, just go ahead and swap it. Okay. Alright, next question. C is equal to 2 times pi times r, where r is equal to 16. And just note that pi is 3.14. Now you can use a 3.14, or you can use a pi button, which is on here. But in this case, because the question says use 3.14, we can go ahead and use that. Okay. If there's a question within your exam where it doesn't necessarily say pi is equal to 3.14, you'll go ahead and use that pi function. Okay. And in order to get pi, there is this shift button. You'll just press shift, and then you'll press this button here, which has got that little X10 on it. Above that, you can see the pi symbol, and that will give us pi correct to however many decimals the actual calculator can hold. And in this case, we're just doing a simple substitution, pi equaling 3.14. So C is the actual variable we're trying to find out, because we can see along here, no pun intended, there is no C equaling to something. 2 times pi, which is 3.14, times radius, or r, in this case it's just 16. Okay, so we've got this formula now. 2 times 3.14, which is pi, times 16. Go ahead and get your calculators out and see what you get. In my case, I get 100.48, and that would be the answer for that. That one was just a simple, straightforward substitution. This one, a bit different, because the number that was given was equaling to something where the unknown was on the bottom, on the right hand side, so we had to solve for this. You will also get context questions that require you to substitute certain variables as numbers. The only tricky bit with context questions is that you've got to understand what the context is talking about in itself. Okay, because you'll see all these letters within a formula. You kind of had to have an intuitive feel of what's going on and where the formula comes from, because these letters that appear here within this set question actually belong to different sets of contexts within the real life world. So in this case, example here, you're going to use a formula, and this is a real life formula that's used. S is equal to d divided by t, or d over t. S is speed, the speed of a certain vehicle, which is determined kilometers per hour. D is equal to distance traveled, which is in kilometers, and T is equal to time. So in order to get the speed of something, it's distance divided by time. You might see this pop up within science questions. It's also used in maths as well, quite a lot. So we want to determine the speed of a car. So we're trying to find what S is. So before I even look at this, we're trying to look for the speed of a car. So S in this case is the thing we're trying to find out. It's unknown. So we're looking for the speed of the car, which has traveled 2,000 kilometers in 4 hours. So it's traveled 200 kilometers, and the context for distance traveled is the letter D. So S is the one we're looking for. Our distance is equal to 200. And in 4 hours, if time is measured in hours, our time is just 4. So now we can just plug in the letter D and the letter T as 200 divided by 4, and this would give us the actual speed the car was going in kilometers per hour. And 200 divided by 4 is equal to 50. Okay, so in this case, our speed is equal to 50. Now, 50 what? Well, the speed is measured in kilometers per hours, so our speed is kilometers per hour. And that makes sense. A car travels 200 kilometers within 4 hours, so the average speed it's going is 50 kilometers per hour. Okay? Now, this is in the context, okay, of something in real life, but most importantly, it's given in a worded format, so you have to answer this in worded format. So you write therefore. So remember, this symbol means therefore. Therefore means just using the information or the calculations that we've made. We'll say therefore the speed of the car was 50 kilometers per hour. Okay. The format is in sentence form, so when you answer questions within your test or your exam, you have to answer it in question form as well. The last example, and hopefully I have enough time, we've got about 2 minutes left for this recording. Use logic to determine the distance traveled if a car was traveling at 80 kilometers per hour and it traveled for 9 hours. So in this case, the speed has been given to us as 80 kilometers per hour. So the speed is equal to 80. The distance, well, we're trying to find out what the distance is because the question says determine the distance. So RD, we don't know. And it traveled for 9 hours, so our time measured in hours is just 9. So speed, or if you're looking back at the initial question, S is equal to D over T. We know what our S is. 80 is equal to the distance, which we don't know, divided by the time traveled, which is 9. So we're going to try to figure out how we would get this. Remember in trigonometry, when the unknown is on the top, you get the bottom and you multiply with what's on the left hand side. We're literally going to do this to get what our distance is. So 9 times 80 is 720. And this was the distance that it traveled. So in this case, it was 720 kilometers. So you would answer this as therefore the car has traveled 720 kilometers. I'm going to have to wrap it up here because I've only got about 5 seconds of recording. Go ahead and use your logic to determine which questions you need to do.